there, and welcome back. I am looking for the page numbers that go with this particular lesson so that I can tell you how to refer to that in your book. And it looks like we're talking about pages 97 through 100. So 97 through 100 are the pages in your textbook if you're using the text. In your student work text, you were on page 43. So a circuit, let's start out with that word. A circuit is a closed loop of energy, I could say, with at least one power source and one device connected by wires. And I'm going to try to show you a picture of a circuit. So if you need to stop your video and finish copying, that is fine. Here is a picture, hopefully, of an electrical circuit. If you have ever built a house, you will be familiar with electrical circuits because you have to decide which appliances, or your contractor will decide which appliances to put on different circuits. You don't want to overload a circuit. But here is not what I'm looking for. My father was an electrical engineer of sorts, and he would understand this completely. Let's see. For some reason, I thought I was going to find a really good example here, but I'm not. So let's just look at this one. So remember what our definition is. A closed loop with at least one power source, that would be the battery, and one device connected by wires. So this is a very good picture of a circuit. One power source, one device, and some wires. All right, the next word is conduction. Conduction is energy transfer by contact. So to give you an example of this one, I want you to imagine that there is a pot of boiling water on the stove, that it's made of cast iron. Okay, the pot is cast iron. So I walk over to the pot and I put my hands on the handles of the cast iron to pick it up. What's going to happen? I'm probably going to drop the pot because it's going to feel very hot to my touch. It's because the heat source and the pot are in contact. The pot is heating up. And when I put my hands on that pot, that transfer is going to carry over to me. So conduction is the movement of heat or energy from one thing to the next by contact. Convection, on the other hand, is energy transfer that occurs by the movement of a liquid or a gas. You can think of a pot of soup on the stove, and as that pot starts to boil, that liquid starts to move, you're going to get a transfer of energy, and that is through convection. A current is a flow of electric charge And we really could stop there, but I want you to know where this comes from. As in electrons through a circuit. Remember those electrons that we talked about way back, what seems like an eternity ago? And I will go back to show you those. Let me go to I'll have to look, here we go. Remember this model that we drew, and we said that these are electrons right here. That's what we're talking about, electrons. When you get those flowing in a current through a circuit, you have electricity. You have a type of energy. And electricity is energy movement by electrical currents. So you have that movement of currents that is electricity. Okay, this next one is a huge mouthful of terms. This is electromagnetic spectrum. Electromagnetic spectrum. And we're going to look at a diagram of this on the next page. So let me give you the definition, and then we'll worry about that when we get to our next page. The electromagnetic spectrum is the range of all frequencies. And I'm going to explain what frequencies are. The range of all frequencies of electromagnetic radiation. And I'm going to show you the picture right here. So we're going to look at that and talk about that in just a second. Frequency. I'm going to try to draw you this one. Is the number of waves that pass a point in 1 second. So let me try to draw something here. I'm going to make a diagram, and I'm going to need 2 copies of it. So here's 1 copy, and then let's make a copy of that. And I know this is a little harder for you to do. You don't even have to do it. You can just watch what I'm doing here. Okay, so I want you to imagine that each of these is 1 second long. So here is 1 second, which is not a lot of time. It's just a blink. 1 second. And here is also 1 second. So I want you to just watch what I'm doing. I'm going to draw some waves in here. Now remember that these are both 1 second intervals. So here comes this guy. It's not very good, is it? And then here's this guy. Which of those has the higher frequency? Which one's moving faster? Well, the one on the left, because I have been able to squeeze a lot more peaks and crests and valleys, crests and troughs into this one Then I have this one. This fella's kind of slow and slow and slow. This first one is more of a high frequency wave. So you set your time limit and then you see which one is moving faster. Frequency. Okay, radiation. This is one I'm sure that you've heard of, but do you know what it means? Radiation is energy transfer by movement of waves or particles. It's not always dangerous. I don't want you to have in your mind that radiation is always a bad thing. So the pictures that I just drew for you where energy is traveling in waves, that's radiation. That is a type of radiation. Now it could be dangerous, it could be not dangerous. And when we look at the electromagnetic spectrum, we're going to know which that will be. Wavelength. You've heard the expression, we're just not on the same wavelength. Well, that's sort of going to be illustrated right here. The wavelength is the length from crest to crest in a wave. So I'm going to try to draw a wave. Bear with me here. That's not too bad, I guess. This is called a crest. This is called a crest. And this is called a crest. This is called a trough. There's a trough. There's a trough. Here's a trough. Or part of one. So a wavelength is this distance right here. It is the distance from crest to crest. And because my waves are not real straight, that's why. Let me try it on this crest and this crest are a little more. This is because I can't draw that we're having this issue. So crest to crest, that is a wavelength. So it's the point from here to here, wavelength. So if we go back up here to this diagram, you can see that this high frequency wave has a much shorter wavelength than this long wave over here. You see the wavelengths are shorter in the high frequency than they are in those long, slow waves. Okay, let's take a look at the electromagnetic spectrum, and I think I'm going to stop this video and we'll pick up on that one in the next video.